For this demo, I'm going to talk about suitability analysis, which is a very complicated topic. So we prepared a set of new data for you to help you through the process. Once you download this data and unzip it, let's go ahead and browse inside the folder. So if you open up the suitability analysis folder, you will see 4 files listed in here. There will be a suitability maps document, which is an ArcGIS ArcMap document. We will open that in a second, which we'll be using. I've already created a template for you. We have our raw GIS data, which will have all the raw data as mentioned in the chart. We have our suitability matrix chart, and we'll be putting our process GIS data in the process GIS data folder. Let's go ahead and open the chart. This is just simply a Microsoft Word document, and it will explain kind of what we're doing and why for the suitability analysis. For this suitability analysis, we have 2 basic general issue topics. We have suitability criteria for infill building development, and then we have a second chart that is more for park, open space, and green infrastructure. You'll notice there are some scores that are different. In particular, parcels and FAR, floodplain, census block data, that are different between the two because we're looking at 2 different issues. For example, the civic floodplain. We have, within this, I've combined all the floodplain into one layer. We have a high hazard zone, a 100-year zone, and a 500-year zone. This is categorical data, which I'll show you in GIS. We have some thresholds. We have qualitative scoring, so low suitability for architectural or building or infill development, medium and high suitability, which get value scores. So the lower the score, the less suitable for development. The higher the score, the more suitable for development. And then we have weighting, which you can get through survey, interviews, focus groups. But essentially this is describing how important the information is to the community. And then we have a total suitability score for each category, which is simply multiplying the score by the weight, which equals your total score. And then we've included some scoring logic. For instance, the City of Boulder has already expressly denoted high hazard zones cannot have any new architectural, building, dwelling, business, commercial development that requires new buildings. And so we score that the lowest in the suitability, A1, and then we weight it because in reality it's already kind of set in stone, and so it's kind of the least suitable on the scale, it's kind of the least important on the scale, so it has a small weight, which is 0.125. In contrast, the 500-year flood does not happen all that often. Building can happen there. It's probably more suitable than building in the 100-year floodplain, and so we give that a 3. And it is fairly important. We still want to protect it, and it's still more suitable for development, so we give that a 0.75 or 75% out of 100 or 1, which gives us a weighted score of 2.25. And the reason this is the logic says a large part of downtown Boulder is in the floodplain. However, the 500-year floodplain is least likely to happen and can be mitigated through proper construction methods. So, again, that's just the floodplain. So what we're going to do now is I'm going to show you how to add these fields and values into GIS. You will notice, however, in your data package, the floodplain, the parcels, and the census will have the qualitative scoring, the score, the weights, and the total scores already in there for you. The reason I am showing you this is simply that one layer we will do together in class, but if you want to go back and look at how we did it, this video will show you how to create this information in GIS for your own layer, which is more related to your issue. So with that, let's go ahead and close the chart, or minimize it because we will need it.